In a certain neighborhood, there is a 0.30 probability that a randomly selected person of the population owns a dog. Assume 25 people are randomly selected. Find the probability that all of the selected people own a dog. So, this is another instance of a binomial probability distribution. The 25 people that are randomly selected are considered the 25 trials, so n equals 25. There is a probability of success, which is to own a dog. That's 0.30. There is also a probability of failure, Q, which is 0.70. It's 1 minus P. And then X changes depending on the particular question. So in A, find the probability that all of the selected people own a dog would be the same as saying, what's the probability X equals 25 people? Find the probability that 25 people own a dog. So probability X equals 25. Now I'm going to use the binom functions in the calculator, and just to remind us, binom PDF NPX is for exactly X, and then binom CDF NPX is for at most X. So it's the cumulative probability up to and including X. So if this said, what's the probability X is less than or equal to 25? Then we would use binom CDF. So we're going to do binom PDF 25, comma, 0.30, comma, 25. So it's the second button, vars, and we can scroll up to get to binom PDF. And then some calculators are set up where you just do n, comma, p, comma, x, and then close parentheses. So n is 25, p is 0.30, and x is 25. And then we get this number, 8.5, e negative 14. So what that means is 8.5 times 10 to the negative 14, which would be 0 point and then 13 zeros. And then 8.5. And rounded to 4 decimal places, it's just 0.0000. So there's a pretty close to 0% chance that all of them will have a dog. Okay, B. Find the probability that exactly 15 own a dog. That's probability X equals 15. So it's going to be a binom PDF again, 25, 0.30, and then 15. And then if you enter this into your calculator, you will get 0.0013. C. Find the probability that the number of selected people that own a dog is 8 or more. So the probability X is greater than or equal to 8. Once we see this, which indicates a cumulative probability where we're adding more than one probability, we're going to need to use binom CDF. But first of all, binom CDF is X less than or equal to some number. So this is equal to 1 minus probability X is less than or equal to 7. So we're going to need to type in 1 minus first. 1 minus binom CDF 25, comma, 0.30, comma, 7. So I'll show you how this works. So now we do 1 minus second vars. Find binom CDF 25 people are being selected. Probability of success is 0.30, and we want at most 7. And we get 0.4882. So we would be able to state that it is unlikely that all 25 would have a dog because the probability is less than 0.05, but it would be unusual, but it would not be unusual for more than or 8 or more to have a dog, because that probability is greater than 0.05. You are given a multiple choice test with 100 questions, and all of your answers are guesses. Find the mean and standard deviation for the number of correct answers. Now this is a binomial. There's a fixed number of trials, n is 100. There's a probability of success, and it remains the same for the entire scenario. We do have to specify how many choices there are. Multiple choice test, that was not included in the original problem. So there's 4 choices each. So that would have to be specified. So the probability of guessing the right answer is 1 out of 4. So 0.25, and the probability of failure, which is Q, would be 1 minus P, so it's 0.75. All right, so choices are A, B, C, or D. The probability of selecting the correct choice is 1/4. The formula for mean, mu, is n times P. So it's 100 times 0.25, so it's 25. That makes sense. It's the average would just be 25, because there's a 1/4 chance. It's equal to basically the percentage that you're likely to get correct. It's the expected probability. Now, the standard deviation is equal to square root of n times p times q. So it's the square root of 100 times 0.25 times 0.75. So here we get 4.3301. Rounded to 4 decimal places. So there's your mean and your standard deviation. That allows us to find the range of usual values. So for B, the range, we're first going to find the minimum usual value. That's found by doing mu minus 2 sigma. So basically it just means 2 standard deviations below average. So that's 25 minus 2 times 4.3301, which gives us 16.3398. The maximum usual value just means the value that's 2 standard deviations above the mean. So that's 25 plus 2 times 4.3301. We do that, we get 33.6602. So the range of usual values is 16.3398 up to 33.6602. So any number correct in between there would be a usual value. So for example, getting 18 correct would be considered usual. Getting 30 correct would be considered usual, even though the expected number correct is 25. But if a person got 30 correct, that's not unusual. C, would it be unusual for a student to pass? Which means you need to get 75 correct. Yes, that would be unusual. And the reason is, since it is outside the range of usual scores. it would be highly, highly unlikely that just guessing that you would get 75 correct out of 100.